Hello, my name is Zayd and I'm a high school AI developer here at Numu, and this is my Waicy 2025 submission. Now, before we start, I'd like to play three different beating sound machines, and I'd like you to figure out which one is the faulty one.
So, is the faulty bearing A? Is it B? Or finally, is it C? Well, if you chose bearing A, then you'd be correct. This is how most machines grow with faults without anyone being able to differentiate these small acoustic patterns that sometimes can't be even heard with the human ear. And then later, these problems would develop into larger problems, causing more loss to the company and consumers due to the longer need for maintenance time. This is where my project SONEXA plays into action. It is an AI-powered machine health monitoring system designed to detect early-stage equipment failures using sound available 24/7. This AI features an audio spectrogram transformer model or an AST model that distinguishes noises from bearing, propellers, and sliders for both states, healthy and unhealthy. When we discuss the workflow of SONEXA, there are two main points we can dive through. The first is collecting data, while the second is machine learning AI. While collecting data, I started with searching for .wav audio files from several sites, including Zenodo and Kaggle. And to make my own dataset, I then prepared a label sheet for all of these data gathered, and then finally preparing them by splitting all of the 1400 plus files I've gathered into training and testing files, and then converting all of them into MEL spectrograms for the AI to be able to learn. The other part is the machine learning, where I set a simple flowchart to begin with the research phase. And I started with a base model of a CNN, but then quickly discontinued that idea as the quality was extremely low of 76.7%. So I therefore settled with a transformer model, AST, where the accuracy was over 80%, which then allowed me to completely evaluate the model looking at the precision, F1 score, and the confusion matrix. The way SONEXA works is split into 5 main steps as clearly shown. The first step is recording the audios. This would be done by setting a microphone next to the running machine, and it would record a 10-second clip every 15 minutes, which then leads us to the second step of it being saved in a folder in the drive. The third step is giving the AI the type of machine and the machine model. This would later come helpful to the AI in order to give us an easy follow guide to solve this issue. The fourth step is the AI predicting the issue, which will then be shown with a percentage confidence, then finally leading us to the fifth and final step of receiving a step-by-step guide on solving this issue with the help of ChatGPT. Now, allow me to show you this architecture working live in this demo. Now, the first step in the demo, as seen in SONEXA's architecture, is a program would record 10-second audio clips for every 15 minutes and then save them on a folder. This was done with the help of Python and Cursor. So this way, the AI would have many audio clips and can check the most recent one to make sure no issues popped out immediately. And so for this demo, I will be testing out an unhealthy slider to see if the AI can predict it correctly. So after we start running the code, see, this way, right now, the audio clip has been saved on Google Drive. And now the cursor is telling us that after 14.8 minutes, it will start recording the next audio clip. However, right now, we won't be needing that. So after that, after the audio clip has been saved, we can head immediately onto Google Colab, where we could predict our issue. So after running our prediction code, the Google Colab will check the latest recording as it saw, and then we'll be running the AST prediction. And so after some time, it detected that there is a slider unhealthy issue with a confidence percentage of 60.74%, which is a pretty valid percentage. And so after that, in order to get our final solution, and let's say we wanted to solve this problem, we would run the final code where it would reassure the prediction and predict it again, and then give us the solution. So as we could see over here, it gave us that the problem was slider unhealthy with the confidence again. And so right now we have this option to enter the machine's name. So this way it would tell me exactly what the problem is. So let's say I have a problem in my 3D printer. And so it asks me the type of the machine or the machine model. So let's say I have a 3D printer of a bamboo X carbon. So after I press on enter, it will give me the possible issues and solutions I could do for this for the machine. Okay, so the AI immediately gave me that I have to do immediate safety measures, such as shutting down the 3D printer, making sure there's no electric leaks going on, giving me extra steps for troubleshooting and inspections. What could possibly be the root of this cause, and some hypothesis, and then some guidance and trying to help me. For example, lubricating or cleaning. So this way, I would be able to solve the problem with zero risks, and this way we would prevent any extra problems happening before the slider completely breaks. SONEXA's benefits are many, as it saves money, it reduces risk of injury, and it saves time. Thank you for listening.